In the last video, I showed you a class that appeared to have no encapsulation principles, and we saw this created several problems. Allowing direct access to data on an object can bypass checks and operations. It encourages an interdependency or coupling between the calling code and the class. This interdependency makes it hard to change the class without impacting the calling code. For the previous example, I showed that changing a field name broke the calling code. And I also showed that the calling code had to take on the responsibility for properly initializing a new player. Encapsulation solves all three of these problems. Now that I've shown you what not to do, let's create a new class that actually has proper encapsulation. Open the project panel, right-click on the SRC folder, select New Java Class and enter Enhanced Player. The difference here is I'm going to create my three fields as private. Private string name, private int health, private string weapon. And here I have the name of the player, the health and the weapon, and they're all declared as private. Next, I do want to create a constructor. I'll first create a constructor with three parameters. And what I'm going to do is use this constructor to make sure the health field stays in the range of 1 to 100 with an if-else statement. If a user passes a value that's less than 1, I'll just make the health 1. And if the constructor is passed a value greater than 100, I'll make the health 100. If health is less than or equal to 0, this.health equals 1, else if health is greater than 100, this.health equals 100, else this.health equals health. This constructor gives me a little more control about how a new player is created. Now, I could put more validation in there to check the length of the name or to make sure the name I get isn't null, for example, and likewise do some validation for the weapon. I won't do that right now. Let's create an overloaded constructor that doesn't have health or weapon because I'll set these to some default values. This constructor will have one parameter only, name. I'll edit the generated code and instead chain constructors by calling the three-parameter constructor, passing the name value, and default values for health and weapon. This will make creating a new player easy with only a name needed. I will make the default value for health to be 100, and I'll make the starting weapon a sword, this, and the arguments name 100, and the string literal sword. With this constructor, I can create a new enhanced player by just passing the name of the player. And I'm guaranteeing now that the name, the health, and the weapon are initialized when the class is created. Now let's just copy the three methods we had for player. I'll copy lose health, health remaining, and restore health methods from the player class and paste them in the enhanced player class. Okay, now I have a better player class, which I called enhanced player. I'll go back to the main class and main method and create a new enhanced player. Enhanced player Tim equals new enhanced player, and I'll pass a single argument Tim. I'll print out the initial health for the newly created object. Now obviously if I run that, I should get initial health is 100. But what if I use the other constructor, pass 200 as the health and sword as the weapon? Let's do that and see what happens. If I run that, you can see that even though I passed 200 as health, the health is still 100. Hopefully you can see straight away I've got more control. There's no way for the calling code to change the health except to call enhanced player's methods to do it. This gives all the control back to the enhanced player class. Just to be clear, this is encapsulation. This is what I'm doing by making my fields private. I'm making sure that the fields within the class aren't accessible to any classes that are outside of the enhanced player class. And now let's say I wanted to change the field I use for the player's name, changing it to full name from name like I did with player. But this time I want to show you another feature of IntelliJ that's really cool and enables you to do a quick rename. If you actually click on what you want to rename, name in this case, and right-click, go to refactor, then choose rename. And now if I go back and change this, the part that's in blue, I change that to full name. You see it turns pink. Before hitting the enter key, I can scroll down and see every instance of name has been replaced with full name. And if I press enter, I get a pop-up that asks me if I want to change the parameter names of the constructors. And this really is up to me. But this time, I'll select all and hit OK, and it changes the name to full name in our code. And for good measure, Let's change the name of the field health to health percentage. This is because this field is really a percentage and not a fixed value. A player that's totally healthy means he has 100% health, but near death is 1%. Again, I can select refactor, rename, and change that field to health percentage. And press enter. This time, I won't update the parameter in the constructor. And I want to do that this time because I want you to see that the parameter name has no effect on how the code works. The point is, I've now changed two field names, but check out the code in the main method of the main class. It didn't have to change at all. It runs exactly as it did before. The structure to create a new player hasn't changed, and the method name to get the health didn't change. This means the code here, the calling code, has no idea what the internal naming was for the fields, and it doesn't need to. I'm just calling this health remaining method, and it's doing the rest for me. This is another cool feature of encapsulation, which is we can make all these changes to this enhanced player class. We can create private fields and private functions that we don't want to be exposed to any other class, and I can change those names at any time in this code without affecting any other code. That's really one of the huge benefits of encapsulation. Changes made do not affect any other code. It's like a black box in many ways. What I'm saying here is the only way to create an enhanced player object is to call the constructors we have defined, and those constructors have got rules in them for what health can be. But the other thing is I can't bypass the enhanced player's methods and change the health field directly. I haven't provided a mechanism to change the health by any other means, except to use the methods lose health or restore health. I can pass the initial amount of health in the constructor, but I can't change it after that, like I did when using the player class from the previous video. Using the player class from that video, I could set the value, and I actually changed the value midpoint when I shouldn't have, but the enhanced player class has full control over its data. This is why you want to use encapsulation. We really want to protect access to our object's data. We protect the members of the class and some methods from external access. This prevents calling code from bypassing the rules and constraints we've built into the class. In this case, as I said, I'm using it to make sure that the enhanced player, when I create a new instance, it's initialized with valid data. But likewise, I'm also making sure that there's no direct access to the fields. That's why you want to always use encapsulation. It's something that you should really get used to and use. To create an encapsulated class, you want to create constructors for object initialization, which enforces that only objects with valid data will get created. Use the private access modifier for your fields. Use setter methods sparingly and only as needed. Use access modifiers that aren't private only for the methods that the calling code needs to use. You definitely don't want to be creating code like the player class from the previous video where I created public fields. In the majority of cases, you don't want to give access to other classes because, as you saw, it's more work to make those changes when you change a field name. I did show you a case in the inheritance video where I used the protected access modifier instead of private. This lets subclasses have direct access to these fields for functions they need to perform, but even this should be used carefully and with a thoughtful, planned approach. Okay, that covers encapsulation. In the next video, I'll give you a challenge to give you some practice with encapsulation. I will see you in that next video.